P.2 Cartesian coordinate system. So the first one say to name the quadrant containing the points. So I'm going to list off all the points and then we'll just say what quadrant it's in. So 1/2, 3/2, -2, 0, -1, -2, and -3/2, -7/3. And also if it's not specifically in a quadrant, we can say what axis it's on. Or if it's like would be at the origin, you would just say origin. So where is point A? Quadrant 1. How about B? X-axis. -1, -2. Quadrant 3, and -3/2, -7/3. Oh. Hold on. Make this positive instead. I was like, huh? Just so it's different. Yeah, 4. I was like, why in the world is there?
That's not right.
Yeah, because I had on my paper a different problem, but the book, that was the problem. But then I was like, it's literally the same. Like, it's the same as the one before, so I wanted to do something different. So
Yeah.
I was like, why is my paper not match the book? And then I was like, oh, because it was literally the same answer. Okay, evaluate the expression 2 minus the absolute value of -2. What would that be? 0. 8. -2 divided by the absolute value of -2. Yep. Rewrite the expression without using absolute value. The absolute value of the square root of 5 minus 5/2.
What does it mean without absolute value?
Like, rewrite it so that it doesn't have absolute value bars.
Oh.
But that it means what absolute value means.
So pretty much just solve it.
So,
Can we square the whole thing?
huh?
No. I was just looking at that square root of 5 and it didn't look very happy.
So, basically with these, we just flip them. So this is going to become 5/2 minus the square root of 5.
Oh.
That makes sense.
Okay. You
Thanks.
flip them upside down. I was like, what is that gonna do?
Nothing. Absolutely nothing.
Literally nothing. It's just gonna make the problem more difficult.
It's just gonna look weirder.
Okay, find the distance between the points. So the first one, they literally just give us, if it was like on a number line, -5 and -17. So the distance between the 2 points for that is the absolute value of -5 minus -17. Because distance has to be positive. That's why it's an absolute value. So you can either do it without the absolute value and then just know that your answer needs to be positive, or you can go ahead and put it in the absolute value bars. So what is that going to end up giving me? 12. And that's like literally just counting on a number line. 16, got negative 1, 2, and the 0.2, negative 3. So the distance formula, as a refresher, is the square root of x1 plus x2 squared, or wait, minus, sorry, not plus, minus. Yeah. Starting to second guess myself there. Plus y1 minus y2 squared. And it doesn't matter which one you call y1 or y2 because that square is going to take care of any issues with signs that we would have. So plugging in the numbers, square root of negative 1 minus 2 squared plus 2 minus negative, so plus 3 squared. So that's the square root of 9 plus 36. Right? No. 25. Yep. Wow. Thank you. I was like, something's not right. I was multiplying 2 times 3 instead. And then that's the square root of 34. And you can just leave it like that. You don't need to, like, try to, like, factor out stuff if, you know.
I don't think we could with that one.
Huh?
I don't think we could with that one.
Well, yeah, that one you can't, but I was just saying in general. If you can, you are welcome to, but you don't have to. Are we okay with the formula?
Yeah.
Okay.
Are we getting cookie points?
Probably. Find the midpoint of the line segment with the given endpoints. So now, midpoint, and I am skipping 19 through 22. I'm going to go back to that. We might do it today. I might wait and do it on Monday, so that way I don't, like, show it to you today, and then you have the whole weekend of not doing it, and then come in on Monday and be like, I'm confused. So, 24, we have the points negative 5 and negative 17 again. So I want to find the midpoint between those. So how would I go about doing that?
So you would, like, find the distance and then divide it by 2.
Well, sort of. I'm going to add them up and divide by 2. Because this can be negative. It will be negative in this case because they're both negative. So negative 5 plus negative 17 over 2, negative 22 over 2, or negative 11. So the midpoint is at negative 11. Uh, 28, so the same instructions, they're just actually giving us 2 points now. So this is 5, negative 2, and negative 1, negative 4. So this is the formula that's A plus C, and so that would be A, C, this is B and D. So A plus C divided by 2, and then B plus D divided by 2, and that gives you the midpoint between the 2 points. So this is a giant parentheses basically. So 5 plus negative 1, so minus 1 over 2. And then y is going to be negative 2 plus negative 4, so minus 4 over 2. So we get 2, negative 3 is the midpoint for that. Questions about that? All right, I will go ahead and introduce one of the problems, and then I'm going to save the other one, the harder one, for Monday. So that way you have a refresher on it. And then there's one scatter plot problem that we'll also do on Monday, just so that way you've kind of seen it. We don't necessarily do a lot with it in here. I need to look and make sure, like with the exam, that see what it says about that. But usually it's not that big of a part of pre-cal. It's kind of just like here's an introduction so that when you get to stats, you kind of know what you're doing if you decide to go that route. But these ones say to find the area and perimeter of the figure determined by the points. You're in stats, I know. We're going to get there, I promise. So, 20 gives us the points -2, -2, -2, 2, 2, 2, and 2, -2.
Why couldn't this have been problem 22?
Problem 22 is much harder.
I'll stick with this.
So I'm going to go in order. I'm going to call this point A, B, C, and D. So typically when we're doing these problems, okay, if we're not sure what the shape is, we need to find the distance between each one of them, okay? However, if it's one like this, we can plot the points, and we're going to see that. What shape do you think this is going to be?
A square.
A square. So a square, all sides are the same. So how many distance formulas will we need to do for this one? 1. That's not going to necessarily be true in all of the problems, okay? So I am going to initially go ahead and just graph the points. But what I will tell you is you can't just look at the graph and be like, oh, the side length is blah, blah, blah. Like, you need to actually show the distance formula. That's the whole point of this, to get your perimeter and area. So I'm going to plot my points. That really doesn't look like a square, but I promise it's the best I can do. I promise it's good.
I promise I'm good. I promise I'm good.
So then I'm going to do the distance between A and B. So I always kind of like show what I'm solving for so that when you get to the other ones, you know. And so then it's the square root of -2 minus negative, so +2 squared plus.
Does that say A plus B in the parentheses?
No, it's like an arrow, so like A to B is what
Oh,
it's a little,
okay.
yeah, it's a baby arrow. I don't think that made it any better.
No, it's just a block.
It's an arrow with pretty colors.
There.
Thank you.
Right.
So then the other one is going to be -2 minus 2 squared. So this one goes to 0, so I'm left with -4 squared, which is the square root of 16, which is 4. So since I can tell that it's a square, I'm good to go. Sometimes what they'll do is they'll give you points so that the square is actually crooked. So you may not know initially that it's a square, in which case then you need to do others. This one is obvious that it's a square based on what it's given, so we can just assume that it's all the same. So how do we find the perimeter of a square?
Add all the side lengths together.
So 4 times the side length is going to be 4 times 4, which is 16. So my perimeter is 16. And then what is the formula for area of a square? Side squared, so it's going to be 4 squared, which is also 16. Obviously, that won't always be the case. It just happened to be in this one. With a triangle, obviously you're going to have to know those formulas for that. There's one of the problems in here that is technically a trapezoid when it gives it to you, which I don't expect you to know like that area formula, like just off the top of your head. So I usually don't assign that problem, or if I assign it, it usually doesn't go very far, so I probably won't assign that problem. People get super confused with it, and it just takes them a hot minute to solve it. I don't know if it's this section, but there is a section that has a question that says, decide if the points given give you an equilateral triangle. So you have to go through and you have to find the side lengths of every side. You can't just like assume, things like that. So I usually end up assigning the triangle problem with this section so that you're used to it by the time it rolls around. But we'll do the rectangle one on Monday, so it's a little bit harder. It's not like significantly harder, but that way you see it, on Monday, and then we'll do the scatter plot problem, and then you'll have the rest of the time to work on it. P3 notes will be due on Tuesday, so if you want to get ahead on that this weekend.